This is a scholarship level question, but you can definitely answer this as a level 2 student. You have everything you need just with your kinematics equations. So in this situation, it's related to the rocket launch from the previous question, where your rocket starts here, and in this competition it needs to go 100 meters to the right and 10 meters up. Right, there's like a target at that position, and you launch the rocket at an angle of 45 degrees. However, you need to set the initial speed, right, the resultant vector, the magnitude v, in order for its path to hit the target. So this is a two-dimensional kinematics problem, right, because we're going to the right by 100 meters and we're going up 10 meters, and our velocity, capital V, can be split into horizontal and vertical components. So a couple approaches to this. I'll show you what I think is the easier way, and then I'll give you a hint as to the harder way, and you should also try that. So why this is tricky is because it's in 2 dimensions, right, and it's 10 meters off the ground, so it's not like symmetrical. If it came back to the ground, that will be a lot easier. So let's start forming some equations. So let's define up as positive and to the right as positive. So in the upwards direction, what do we know? Well, our initial velocity is v sine 45 degrees, right? Now we don't know what v is, but we can express it as, we can express the initial velocity in terms of v. We know acceleration, negative 9.8 meters per second squared. We know we want to reach a height of 10 meters, and that's upwards, so that will be positive 10. What else? Do we know final speed? Nope. Do we know time? Nope. Okay, now let's have a think in the horizontal direction. Initial speed, like before, is v cos 45, which happens to be the same as v sine 45. Acceleration is conveniently 0, and distance is 100 meters to the right, so it's positive. Cool. Now, how do we connect these 2 directions? Well, you'll know from kinematics, the thing that connects vertical and horizontal directions is actually time, which we don't know. However, we do have 3 knowns, right? But with the initial velocity being in terms of another unknown. So having a look at our kinematics equations, the equation that connects VI, A, D, and T is our trusty old D equals VIT plus half AT squared, right, our quadratic. So in both directions, we can substitute in our known values. So I'll just write out the equation twice. Right, so on the left-hand side, we're working vertically, on the right-hand side, horizontally. So substituting in our values vertically, we have D is positive 10, VI is V sine 45. Now, if you know from maths, sine 45 is actually 1 over root 2, so you could put that in now, if you're more comfortable with that. Plus half times A. Well, half of A would be negative 4.9, and then we have, oh, I missed a T there, and then we have T squared. Cool. And in the horizontal direction, D is 100, A is 0, so that term disappears. VI is V cos 45 times T. Cool. Now we are solving for v. Now looking at this, on the left hand side we have a quadratic equation, on the right hand side a linear equation. So there's two ways you could, well, multiple ways you could solve this. You could rearrange for v, equate them, so we'd be eliminating v, we then solve for t, and then back substitute to solve for v. That's probably easier. It sounded like a lot, but the alternative is we solve for t, but for a quadratic we would need to use the quadratic formula to get the two solutions, and then excuse me, we would try each solution. So I recommend you try that second one as practice, but I'll be going through the slightly easier algebraic one. And in both cases you can graph or use your calculator to find the solution. So on the left hand side, rearranging for v, we would get add 4.9t squared, divide by sine 45 times t. So v is 10 plus 4.9t squared all over, I'll put the t out the front so it's a bit easier to read, sine 45. On the right hand side, divide both sides by cos 45 times t, so 100 over t cos 45. Okay, so now we've rearranged both sides for v, we can now equate. So we'd get 10 plus 4.9t squared over t sine 45 equals 100 over t cos 45 degrees. Now you might be looking at this and being like, well, what? Fair. So you could cross multiply and form a quadratic, or at this stage you could actually just graph both sides. Right? So I encourage you to try that. I'll rearrange just for completeness. So multiplying across, 10 plus 4.9t squared, all times t cos 45 equals 100 t sine 45. Now expanding the left hand side, 10t cos 45 plus 4.9t cubed cos 45 equals 100 t sine 45. Subtracting 100 t sine 45 across and putting the cube term at the front. All equals 0, factorizing the second two terms to get t equals 0. Now when we're at this stage, we have a t cubed term and a t term. So it's a cubic equation, and we could use our calculator using polynomial solver to solve it. So I'm going to do that now. Let me just get out my calculator. Let's run away. Oh, it's back. So we go menu, equa for equation solver, polynomial, degree 3 for a cubic. Now the a term is 4.9 times cos of 45. Make sure your calculator is in degrees. Our b term is actually 0. We don't have a t squared term. Our c term is this 10, let's use brackets, 10 cos 45 minus bracket 100 sine 45. Execute. D is also 0. Right, and we hit F1 to solve. And so we get 3 solutions for our cubic. A reminder, we're solving for time, so the only sensible answer would be 30/7. So t equals 30/7 seconds. Now, the question did ask to solve for v. All right, what we found is that at some velocity, at 30/7 seconds, it will reach the target. Now let's find that velocity. Looking back at our 2 equations that we simultaneously solved, this one looks a lot, simpler. So I'm going to back substitute into that. So v equals 100 over t cos 45, where t is 30/7. So menu run math, 100 divided by 30/7 times cos 45, close bracket, that looks good, bed mass is right, to give 33 meters per second. So what does that mean? At 33 meters per second, the vertical component would be something, the horizontal component would be something, such that the path passes through the point 100 to the right and 10 meters up. So we have answered the question, but let's actually go back and check, and I'll show you the graphical method. So after we form our 2 equations right here to simultaneously solve, what we did was we equated them, right? V equals V. Rearranged, we ended up with a polynomial, a cubic. We then solved. However, at this red box, at the equation stage, you can graph it. So we go menu, graph. Let me just clear these 2 formula. And so one equation was v equals 100 divided by, instead of t, we can use x, cos 45. Right, so that's one. The other was bracket 10 plus 4.9 x squared, close bracket, divided by, open bracket, x sine 45, close bracket, 45. Yep. Then we hit draw. Beautiful graph here. Now if you zoom right the way out, you get a hyperbola and then this like other polynomial. And here is the positive intersection, but if we go down, we can actually see it's symmetrical, right? And that's our negative solution, which we can disregard. So going back up to the right in the first quadrant, we can hit gsolve, ISCT. So this point, x, y, what does that mean? So x is actually t in our equation, and y is v. So when time is 4.285, which I think we worked out to be, what was it, 30/7? Yeah, same. The speed, right, the y value, the speed is about 33 meters per second. Right, just to check our answer. Alright, pat on the back, well done, and see you next time.